3.2 Linear functions. Today we're going to be looking at graphs to see if they are linear or nonlinear. Same thing with tables and ordered pairs to see if they're linear or nonlinear functions. With a linear function, it is a straight line, not a curved line, not a shape, just a straight line. So if we look at these functions, it also tells us that linear functions have two variables, one x, one y, and they have a constant rate of change for a linear function. So if we look at example A, we have this u that's not a line. I mean, it is a line, but it's a curved line, so it's not a linear function. So this one is non-linear. For example B, we do have a straight line, so that one is linear. Same thing with example C, we have that straight line, so that one is linear. And then with example D, we have that V-looking line, so that is not a straight line, so this one is non-linear. For example 2, we're asked if the table represents a linear or nonlinear function. If it is a linear function, you're going to have a constant rate of change, which means the change that's happening in your x values is going to be the same constantly, and then the change in your y values will also be the same constantly. So if we look at example A, from 3 to 6, we're going up by 3. From 6 to 9, we go up by 3. From 9 to 12, we go up by 3. For our change in our y values, from 36 to 30, we're going down by 6, so that's subtracting 6. From 30 to 24, we subtract 6. And from 24 to 18, we subtract 6. So here, our slope here, or our rate of change, is that -6 over 3, which is just -2. It is the same constant rate of change, so this is linear. For example B, for our x's, we have 1, 3, 5, 7. These are going up by 2 for each. For our y's, we have 2, 9, 20, 35. From 2 to 9, we go up by 7. From 9 to 20, we go up by 11. And from 20 to 35, we go up by 15. Now, because that 7, 11, 15 is not the same change that's happening, this one is nonlinear. For example C, our x values are 0, 1, 2, 3, so these are going up by 1. Our y values are going up by 2 for each. So this one is constant, all by 1 for your x's, all by 2 for your y's. So this one is linear. For example D, for our x values are 1, 2, 3, 4. So these are going up by 1s. For our y values, we have 16, 8, 4, 2. So this goes down by 8. From 8 to 4, it goes down by 4. And from 4 to 2, it goes down by 2. So because this one is not consistently the same for the change in our y values, we have a non-linear function. If we look at our next part, we're identifying whether the equation represents a linear function. Now, to do this, you can write the equation or rewrite the equation in the form of y is equal to, and then with that, you cannot have any variables in as an exponent. You cannot have x squared, y squared, the square root of x, or x in the denominator of a fraction. So for example A, we have y is equal to 3.8. We don't have an x here, but that's okay, because this is just a straight line that goes through y at 3.8. So this one is linear. For B, we have y is equal to the square root of x. Well, we can't have the square root of anything in a linear function, so this one is non-linear. For C, we have y is equal to 3 to the power of x. Because that x is the power, this one is non-linear as well. For D, we have y is equal to 2 over x. Because x is in the denominator here, this one is non-linear. For E, we have y is equal to 6 times x minus 1. If we were to even distribute this 6, even though we don't have to, we would still have y is equal to 6x minus 6. The x is not a power, it's not underneath the radical, it's not in the denominator, so we have a linear function here. For F, we have x squared minus y is equal to 0. If we moved that y to the other side, we would get y is equal to x squared. Because that x has the power of 2 on it, this one is nonlinear. For G, we have y is equal to x plus 9. This one is linear. For H, we have y is equal to 3x over 5. If we rewrote this as y is equal to 3/5 x, it's still a line, a straight line, because it goes through your origin, because your y-intercept is 0. There is no constant there, and then your slope is just 3/5. So up 3 to the right 5, that means we have a linear function. And then for I, we have y is equal to 5 minus 2x squared. Well, because that x has a power on it, this one is nonlinear. So x cannot be raised to a power, x cannot be a power, x cannot be in the denominator of a fraction, x cannot be underneath the radical sign, y can't be in the radical sign either, or it can't be a y squared. For our next part of our lesson, we are looking at graphing these linear functions and whether or not we have a discrete function or a continuous function. Discrete functions are literally just ordered pairs. Continuous functions is a graph that represents a line. So if we look at this example here with the number line, your discrete functions are just ordered pairs. So like this discrete domain are the x values that are just 1, 2, 3, 4, 5, 6. With your continuous domain, it's 1 through 5. So that line would go through all of those numbers, representing everything between 1 and 5. So that means 1 and 1/2, 1 and 3/4, everything between 1 and 5. If we look at example 4a, it tells us the linear function y is equal to 15.95x represents the cost y in dollars for x tickets for a museum. Each customer can buy a maximum of 4 tickets. Find the domain of the function. Is the domain discrete or continuous? Then graph its domain, or graph using its domain. So with this one, it tells you that the function is y is equal to 15.95x. Represents the cost y of x tickets for a museum. Each customer can buy a maximum of 4 tickets. So if x is the tickets, then we can plug in the values for x to find for y. So we would have 1, 2, 3, 4, so on. If you plugged these in, and you do 15.95 times 1, you get 15.95. If you multiplied it by 2, we get 31.90. 15.95 times 3 gives us 47.85. And then 15.95 times 4 gives us 63.80. So with this, you got to think to yourself, is this discrete or continuous? Now, this one is discrete because 1.5 people can't buy a ticket, or there can't be 1.5 tickets that are purchased. So it's just 1 ticket, 2 tickets, 3 tickets, 4 tickets. So with that, this is discrete. And then you would just have ordered pairs on your graph. Let's say this is 0, 0. Let's say each of these go up by 5. So 5, 10, 15. You go up here. Then 2, 31. Be out here. And your line would just, or your points would just be going up very slightly. And your line would not be drawn in through those points because it is discrete. It's just those points on the x values of 1, 2, 3, 4. For example, B, it tells us the linear function m is equal to 50 minus 9d represents the amount m in dollars of money you have after buying d DVDs. Find the domain of this function. Is the domain discrete or continuous? Explain. So with this one, you got to think, your D is the amount of DVDs. Can you buy half of a DVD? Can you buy 2/3 of a DVD? No, you can't. So this is discrete. And then in order to find what your ordered pairs would be, we would just make a function table with X, our functions, or sorry, this would be D, not X. M is equal to 50 minus 9D, and we're solving for M. So we can use 1, 2, 3, 4. Again, I'm just picking logical X values to use when I solve this. So if I plug in the 1, I'm going to have 50 minus 9 times 1, which is just 50 minus 9, so that's 41. Then I would have 50 minus 9 times 2, which is 18, so 50 minus 18 gives us 32. And then we have 50 minus 9 times 3, which is 50 minus 27, and that's 23. And then for 4, we'd have 50 minus 9 times 4, which is 50 minus 36, and that's 14. So this just gives me ordered pairs of 141, so that's going to be way up here. 232, that could be down a little bit, and then 323, and then 414. So again, it's not continuous, so we don't put that line through those points. And again, these ordered pairs on this coordinate plane are just an estimate of where the points should be or the direction on which they are running. If we look at our next example, it tells us that a cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Does the situation represent a linear function? Now, with this, it tells you that the bar contains 130 calories. C is the number of calories consumed as a function of the number B bars eaten. Now, this represents a linear function, yes, because you can eat half a bar, 3/4 of a bar, 2/3 of a bar. It doesn't necessarily have to be just the whole thing. So with that, is the situation a linear function? Yes. find the domain of the function, is the domain discrete or continuous. Your domain of your function would be your whole numbers, or not whole numbers, any number between 0 to infinity. Okay? So with that, you can use values of 1 or 0, 1, 2, 3, and so on. You're going to use a function. The cereal bar contains 130 calories. The number C calories consumed is a function of the number B bars eaten. So C is equal to the number of bars you eat. So I'm going to change this around to where you have the number of bars eaten is equal to the 130 times, which is the calories. Here, hold on. This should be C, not B. C is equal to 130 times B, because each bar is 130 calories. So with this, if you eat 0 bars, obviously it's 0. If you have 1, that's 130 times 1, which is 130. Then for 2, that's 130 times 2, which is 260. 130 times 3 is 390. So on your coordinate plane, you would start at 0, 0. Then if, let's say, this is 100, this is 200, okay, so we started at 0, 0, 1, 130 is your next, 2, 260, then 3, 390, and then you just draw a line through this with your arrow that goes up. So this would be continuous because, like I said, you can eat half a bar, you can eat 2.5 bars, so this one would be continuous. For this example B, it tells us, is the domain discrete or continuous? Explain. Now your input is your 1, 2, 3, and your output is just the 12, 24, 36. This gives you specific points of 112, 224, and 336. So with this you got to look at what they're explaining. It tells you that your input is the number of stories. Then the output is the height of the building. So you got to think about your number of stories in a building. You can't go and be at 1.5 stories. So it's 1 story, 2 story, 3 stories. So this would be discrete. For our last example that we're going to go over, I'm going to skip this one and look at these. We have A, we're just telling if we have a discrete or continuous function on the graph. If we look at A, we have ordered pairs and only ordered pairs on that graph, so this is discrete. For B, we have a line that's drawn on that graph, so that would be continuous. For C, we have just the ordered pairs, so that would be discrete. And for D, we have another line, so that one is continuous as well.